Hi, my name is Fong Liu and I'm from the National Measurement Institute of Australia. Today I would like to share with you some of the research work undertaken in NMI Australia, particularly in application of CRM in multi-point isotopic calibration for correcting steroid carbon isotope delta measurement by GC-C-IRMS technique. In 2019, NMI Australia released a new pure steroid CRM, MX18, developed under the PCC funding. It consists of 13 steroids distributed into 3 ampoules and is our first steroid CRM certified using a high-precision elemental analyzer technique. This CRM has certified delta values ranging from -13 to -32 per mil. This material had been developed for the WADA laboratories to help them in calibration requirement specified in the WADA technical document for IRMS analysis. The MX18 satisfies the requirement of the technical document because it is a steroid CRM which is traceable to the VPDB through secondary reference materials listed on the IUPAC website. And the delta values provided by the CRM also covers the values typically found in target and endogenous reference compounds. In addition to these, the low uncertainties assigned to the delta values makes this CRM as an ideal calibrant for steroid confirmatory analysis. The current routine approach to GC-C-IRMS calibration is the reference gas approach, where the internal CO2 reference gas has to be calibrated by a steroid CRM prior to sample measurement. The unknown sample is then measured against the reference gas. The multi-point steroid isotopic calibration is a new approach NMIA has adopted since the release of the MX18 CRM. The multi-point approach eliminates the need to know the delta value of the CO2 reference gas. However, setting an approximate delta value to the working gas is a good practice as it enables an analyst to perform a visual assessment of the instrument performance against the required acceptance criteria from the raw delta values. The new approach facilitates calibration of a range of delta values rather than a single point offered by the reference gas approach. When samples and calibration standards are analyzed under the same conditions, the measured delta values for both sample and CRM can be expressed as relative to the working gas. A calibration curve is then generated from the calibration standard by plotting the certified values against the measured values. A linear equation generated from the calibration data allows scale correction of the measured sample to the VPDB scale. Regression factor of 0.99 or greater have been achieved with this approach. Although this concept had been applied in EARMS analysis, this approach has yet been adopted as a routine practice in anti-doping testing. This may be attributed to the lack of steroid CRMs traceable to the international reference materials or the lack of published works in this area. A recent publication by Wolfram and Schimmelmann has strongly encouraged this approach to anchor this type of analysis. The new calibration approach has been successfully applied in certification of carbon isotope delta values of 11 steroids in MX17 urine CRM. This is the replacement CRM for the exhausted MX5. NMIA has received 2 fundings for this certification work. Under the WADA funding, the certification of carbon isotope delta value of 19-noandrosterone has been completed with low uncertainty using the multi-point calibration approach. The certification of remaining 10 steroids is still in progress under the PCC funding. These carbon isotope delta values are expected to be available later part of this year. The outcome from the multi-point calibration approach is best shown by comparing the delta values assigned to the previous MX5 and the current replacement MX17 CRM. The current preliminary delta values of 4 steroids have clearly demonstrated that much lower uncertainties were achieved with the multi-point calibration approach. The finding is further supported by a significant improvement of up to 50% in standard deviation of an external QC material employed during certification. I would like to highlight 3 points on how the multi-point calibration with MX18 can enhance the current passport testing strategies. Firstly, the MX18 CRM is an ideal calibrant because it has been certified with low uncertainty by EA Technique. Secondly, the carbon isotope delta values are most suitable for normalizing measured delta values in target and endogenous reference compounds typically found in urine samples. Last but not least, regular application of a CRM traceable to VPDB enhance accuracy and comparability of measurement data for the Athlete Biological Passport Program. I would like to acknowledge the funding received from PCC and WADA that has enabled NMIA to be part of their anti-doping research program. I would also like to thank the Chemical Reference Values team, especially Jeff Merrick and Dr. Leslie Johnson, for their valuable contribution to the success of these projects. Thank you for watching this poster presentation.